Hello everyone, I am Prajwal and today we will solve this problem, Cosmic Temple. This problem is rated as easy medium on CodeChef and you need the knowledge of DP on trees to solve this problem. So guys, if you haven't read the problem yet, go back and read it, try it out and then come back and see the solution. With this, let's begin. In this problem, we are given a tree with n nodes. So let us take this tree as an example. The number of nodes is equal to 5. Now we define the distance between two nodes as the number of edges in the simple path from one node to the other. So distance of u comma v, this is equal to the number of edges in the path from u to v. Now consider a node I. From every node I, we need to find the summation of distance of from node I to all the other nodes u. So let us say that we consider our I is equal to 1. Then we need to find the summation of distance from 1 to all the other nodes. For example, summation of distance of 1 to u, this is equal to distance of 1 to 1 plus distance of 1 to 2 plus distance of 1 to 3 and so on with 1 to 4 and 1 to 5. So this is equal to 0, this is equal to 1, this is also 1 and the rest is 2. So this is equal to 6. Distance summation of distance of 1 to u is equal to 6. We need to do this for all I and output it in our final answer. In the constraints, we are given the number of nodes from 1 to 10 to the power 6. U and v will range from 0 to n minus 1. So the nodes are 0 indexed. So now let us look at some test cases. In the first test case, we are given a node 0 which has an edge to 2 and 3. Node 3 has an edge to 1 and 4. So now in this problem, we are given this tree and we need to find for all I the distance of I to u and we will consider all u. So to do this, let us do it one by one. First of all, I is equal to 0. So we can say that summation of distance of 0 to u will be equal to distance from 0 to 0 which is 0 plus distance from 0 to 1 which is 2. Next is distance from 0 to 2 which is 1. Distance of 0 to 3 which is 1 and 0 to 4 which is 2 and the sum is equal to 6 as given in the output. When I is equal to 1, we can calculate distance of 1 to u. So this is our I and we need to calculate the sum of distance from this node to all the other nodes. So from 1 to 0 it is equal to 2. From 1 to 1 it is 0. From 1 to 2 it is 3. From 1 to 3 it is 1 and from 1 to 4 it is 2. The sum is equal to 8 as given in the output. So on we can calculate the distance from all the other nodes and we have the required output. So now let us look at the solution. In this problem we are given a tree with n nodes. We define distance from node u to node v. This is equal to number of edges in the simple path from u to v. Our goal is that we will consider each and every node and from that node I, we want to find the summation of distance from that node I to all the other nodes u. So to do this problem, let us first of all look at what we are going to do. Let us say that our root is equal to 0. So this 0 node is our root and this has been fixed for this tree. Now to solve the problem, what we are going to do is, suppose we know the answer for u. So we know the answer for this node 0 and we want to calculate the answer for this node 2. Then what we are going to do is, the answer can be divided as it is equal to distance of node 2 to all the children of 2 and whatever that is left from the rest of the subtree that is not part of the subtree of 2. So let's call this as above contribution. Essentially what we are doing is To calculate the answer for a node, we are dividing the problem into two parts. We divide the nodes as nodes that belong to the subtree of 2 and nodes that do not belong to the subtree of 2. So to calculate this, first of all we will define count of I. This is equal to the number of nodes present in the subtree of I. Next we will define sum of I. This is equal to the summation of distance of from node I to all the children of I. So essentially from each node I, we will store the distance from node I to all the nodes such that those nodes belong to the subtree of this node I. So now how to calculate this count of I? So count of I is equal to 1 if I is a leaf node, else it is equal to 1 plus count of C, where C is child of I. And to calculate sum of I, imagine that you are at a node I and you have few children. So these are all subtrees of node I. So sum of I will be equal to 0 if I is a leaf node, now let us say that I is not a leaf node and we have subtrees of I. So all these represent children of I and each child can have many subtrees. Now to calculate the distance from node I to all the nodes present in the subtree, we know that we want to calculate the answer of sum of I, and we have already calculated the answer for sum of all its children. Sum of all its children indicate the distance from the child node to all the other nodes present in the subtree. So we only need to add the contribution of this extra h to get the contribution from node I to all the subtree, to all the nodes belonging to this child's subtree. Hence we can write this as summation of sum of C, and to add this contribution for all the nodes, it is nothing but equal to the number of nodes present in that subtree, which is equal to count of C, where C is child of I. And over here it has also to be summation. So now when we have calculated this, we can calculate our answer as, so let us consider a tree. Let's say that this is our node U and it has 3 children, C1, C2 and C3, and there is some subtree above. Now we know that we will do a DFS on this tree and we will pass above contribution, which is the contribution of the left out subtree that is not a subtree of this node U. We will pass this from the parent of U to this node U during the DFS. So we can calculate our answer of U. This is equal to the distance from U to all its children, to all the nodes belonging to the subtree of U, and we have pre-calculated this in our sum of I. So this is equal to sum of U, and we know the contribution of the left subtree of all the nodes that do not belong to the subtree of U, which is equal to above contribution. So in this way we can calculate the value of answer of U. Now the tricky part is that when we are going to do DFS, so we iterate for all child of U, we need to pass the above contribution from the node U to all its children. So let us see how do we calculate that. First of all, when we had calculated answer of U stores the distance from U to all the nodes belonging to all the subtrees. So let us say that in the DFS from node U, we will go to C1 first. So to calculate the above contribution for C1, we will first take the total contribution, which is answer of U. Now the contribution of all the nodes that belong to subtree of C1 has to be subtracted from U. Why? Because all those nodes will have one less distance to the node C1 than to node U. So the contribution of all the nodes that belong to C1, the subtree of C1 to the node U is equal to sum of C1 plus number of nodes belonging to subtree of C1. We are adding this count of C1 because when we had calculated the answer for U, we would have counted the contribution of all the nodes present in the subtree of C1 with this extra edge. Now we need to remove this contribution of extra edge, and how many times? We need to remove this count of C1 times. So we subtract count of C1 from answer of U. Now we need to add the contribution of all the rest nodes that are left that are not part of subtree of C1. So we basically have to account for all the nodes that do not belong to the subtree of C1. And how many nodes are there? There are exactly n minus count of C1 nodes. Note that the sum of distance from all the other nodes that are not in subtree of C1 would have been calculated in answer of U. So we basically have to account for the change when we move from U to the node C1, and the change is only equal to this edge. So this edge will be counted n minus count of C1 times. So we can write above contribution as answer of U minus sum of C1 plus n minus 2 into count of C1. And in this way we can calculate the contribution of all the nodes that are not part of the subtree of the current node. So now our answer is simple. First of all, we will calculate count of I and sum of I. This is done using a DFS function. Now we will write solve of. So we have the current node, the contribution of all the rest nodes, which is above contribution, and then we have the parent node of the current node SRC. So first of all, answer of SRC is equal to sum of SRC plus above contribution. Next we will iterate for all children of SRC, and we will calculate the new above contribution. This is equal to this formula, which is answer of SRC minus sum of child plus n minus 2 into some count of child. And we will simply call the new DFS function, which is solve. So we will call solve of child node, then the new above contribution, and the parent node, which is the source node. Finally, we can print the answer. So the time complexity of this code is order of n, because we are visiting every node once in the solve function and in the DFS function. The space complexity will be order of n, because there are order n nodes and we need to create these arrays count and sum. So now let us look at the code. So first of all, we will have some basic variables. We will have the number of nodes stored in n. Then we will have the tree, which is represented in adjacency list representation. We have the sum child, the variable answer, and count subtree. Sum child will store the sum of distance of all children from the node I. Count of subtree will store the number of children present in the subtree of I. And answer will store our final answer. So first of all, in the main function, we will call this function solve. In the solve function, we will input all the variables. We will input the tree and create it. Then we will call the function DFS of 0. In the function DFS of 0, we will calculate count subtree and sum. So first of all, we will initialize count of subtree of source is equal to 1. Then we will iterate over all the children. We will call the DFS function for all the children first, and then we will calculate count of subtree of source and sum of child of source. Next, we will call calculate answer of 0, and finally we will print the answer. So in calculate answer of 0, we know that the above contribution for the root node will be equal to 0. Parent will be equal to -1. So we write answer of source is equal to sum child of source plus contribution of above. Then we need to calculate the new contribution from above, which is equal to answer of SRC. Then we need to calculate the new above contribution, which is equal to answer of SRC minus sum child of child node plus n minus 2 into count of child. Then we will calculate the DFS function for all the children. So we will call calculate answer, child node, source node, and this time we will call the new above contribution defined over here. So in this way we can calculate our answer recursively. Finally, we will print the answer.